Welcome, everybody. Hello, Kelle, and welcome.
Hi, Jesper. Thanks, and good afternoon, good morning, good evening, everybody, wherever you are in the world. Before I hand over to Pepe, I've been asked to say a few words why we think it makes sense to have a desktop conference at all, because we keep hearing in the media, in trade magazines, and when we look at development on software projects, we keep hearing that the desktop is dead. Well, is the desktop really dead? As far as we over here at KDAB are concerned, the desktop is definitely not dead, not even close. So I took the other day to review all our projects that we've done in 2019 and 2020. We are, as many of you surely know, we are a consulting company. We have at any given time, we have 30, 35, sometimes a few more consulting projects running. And I looked through how many of these projects involve desktop platforms. So Mac OS, Windows, any version of Windows, or the Linux desktop, as opposed to Linux embedded, for example, or Windows embedded, or Android, or iOS. And it turns out that about 60%, just below 60% of our consulting projects run on desktop platforms or are developed for desktop platforms, at least to some extent. Now, that does not mean that 40% of our projects are embedded or mobile, because there's quite a bit of overlap. We see a lot of second screen use cases these days, and this is just getting more and more, where a desktop application and an embedded application or a mobile app work together. For example, we've developed software for machine maintenance and configuration, where the complicated setup is done on in a desktop application, where you have a big screen and all the convenient interaction for simple and fast typing and so on. And then there's also the machine control panel, and the operator may have a mobile app on their phone so that they can get notifications about something being wrong with a machine, and possibly being able to get a first idea of what is wrong before they even start to interact. We also see a few projects where we would typically consider them as an embedded device, because they have one single purpose, but where the operating system that is run is a desktop operating system. I see somebody in the chat saying we can't hear you. Can anybody hear me?
We hear you just fine, Kelle.
Okay, great. So in these applications, this is a screen, this is a desktop commodity hardware, because that's typically cheap. And these would be devices that are rolled around on carts. It doesn't matter if the desktop computer is heavy, and these devices often connect to something else, so they will always need to be plugged into mains power anyway. And our customers in these cases sometimes decide to actually run desktop OSs. So, and then obviously we develop using one of the Qt desktop versions for that. One of the things that annoys me a lot is that these days there are so many applications that are built on top of Electron. Now, technically, you could consider them a desktop application, but of course, they are developed using intrinsically mobile technology. And for example, we use one chat system over here at KDAB called Rocket Chat that has an application built on Electron. And then I use another chat application for communication with my family, yet another chat application for communication with my sports buddies. And these are all so heavy that it's almost like you need one core per chat application. So, well, with slightly exaggerated, but not a whole lot actually, of the 8 cores in my computer, 3 go to the 3 chat applications, and that's just not useful and also not a good use of energy, electricity. So this would really be a case where a native desktop application would be very, very welcome. Then we have a lot of projects where we develop very data-intensive 3D visualizations. And while things like WebGL have made quite a lot of progress, there is still a long way to go for these to handle the vast amounts of data that these applications consume and display. This would typically be in the fields of medical technology or computational biology, molecular biology, as the example that you can see in the picture here. This is a visualization of certain proteins in a cell sample, and there are huge amounts of data, and there are very complex computations going on, which would only be possible on desktop hardware. So that was the brief introduction or the brief motivation that I wanted to give, why the desktop is far from dead, why we at KDAB here think the desktop is and will remain an important platform or an important set of platforms, and why we decided to run the Qt Desktop Days, because we think the development of desktop software using Qt and QML deserves more attention than it otherwise gets. Thanks a lot, and back to you, Jesper.
Thank you very much. The next speaker that I would like to present to you now is Giuseppe D'Angelo. There he is.
Okay, seems to be working.
Welcome to you, Pepe. And
thank you.
Thank you for joining us here at the Qt Desktop Days.
I'd like to share with you some insights about what can you expect in Qt 6, the next version of Qt, and I would like to focus especially on desktop-related changes, desktop-related improvements that Qt 6 will bring to us. So just about me, yes, I am the new kid in the block here in KDAB. Well, maybe not kid anymore, but yeah, I'm still kind of new. I've been using Qt for almost 20 years now, I could say. My day-to-day life is I'm a developer, so I'm a programmer, like many of you are. I'm also a trainer. I tend to share my knowledge about Qt, C++, and related technologies. And I am quite active within the Qt project itself. I'm an improver in that project, so I regularly contribute code, bug fixes, new features to Qt. So that's what I think makes me qualified to tell you what's happening in Qt 6 at the moment. So let's discuss a little bit about where we're getting there in the first place. So why Qt 6? Why jumping a major version? Why not just keep going with 5.16, 17, 18, keep going forever? There are many good reasons, mostly technological, if you want, or technical. The idea here is quite simple, is that Qt 5 has accumulated all over the years some architectural decisions that were good back at the time, but today they would need to be reconsidered. So Qt itself has a very strong history of keeping compatibility with existing software, but every now and then it comes to time where we have to break this compatibility, and therefore we can take that chance, that opportunity to bump major version if you want, to clean up the insides of Qt, to re-engineer some features, change a few of the assumptions that were made when Qt 5 was developed into a new evolution, into the next step. Okay. So at a very basic level, if you want, the biggest difference for applications is that applications will need a recompilation when you target Qt 6. That's not needed when you target Qt 5. So at the very minimum, that alone warrants a version bump. But of course, there is so much more. So if I have to summarize a little bit about what are the design goals of Qt 6, the first and most important one is keep as much compatibility with Qt 5 as possible. We don't want to just break all the software out there. The millions of lines of code that have been written against Qt 5 need to be working. So end-user applications should be affected as little as possible. Of course, something may break here and there. I will discuss something else in the next few slides. The other important goals are going to be, first and foremost, re-engineer the property system, one which is foundational. I'm pretty sure I've talked about the property system in hundreds of trainings, hundreds of talks that I've given about Qt. It's one of Qt's central features. And I'm going to discuss what's going to change there, in particular, the idea that we're going to add property bindings in C++. At the second level, we want to improve QML as a language, as well as the other bindings that are targeting Qt. Right now, Python is probably the most famous one. But in general, we want to improve the situation regarding the dynamic languages that are based on top of the C++ libraries. And so what happens there, again, I'm going to show you. Then we have to discuss a little bit about what's happening in the landscape of 3D APIs. These days, there is no longer just one universal 3D API or API to access your GPU. There are many, depending on the platform, and the Qt must give an answer to that. So which one to use on which platform. And finally, we want to take this opportunity to modularize Qt even more. Qt 5, I believe I counted the other day, is something like consists of something like 55 to 60 libraries. That's a lot inside the Qt offer itself. Maybe some of those could be unified. Maybe some of those need actually to be split, or maybe some of those may need to get out of Qt and be released separately, so that Qt does not become this massive, huge set of libraries that actually has a problem when we talk about evolving Qt itself. Having so many libraries inside Qt itself make it kind of slow for Qt to evolve. And yeah, as I was mentioning, pretty much we want to keep compatibility with existing code as much as possible, which means we want to keep all the good parts of Qt. Qt is renowned to be very easy to use, very intuitive to use. And yes, even if I know that the new C++ guys, every time they see a row pointer, they start screaming out loud, please do understand, this stuff comes from 25 years ago. There is an history behind it. And it might not be idiomatic anymore, but still makes it for very easy to use, very discoverable APIs. The documentation, the developer support around Qt is excellent. We don't want to just change everything, and now all of a sudden, all the random notes and all the blog posts that we made about Qt become completely useless. We still want Qt to be a great cross-platform application framework, meaning that inside any given application, we want to make it like 90% very easy to achieve and 99.9% possible by using Qt. There might be at 0.1% of things that are just outside of Qt's scope. So for those, you need to get your hands a little bit dirty. But nonetheless, we want to keep Qt as good as it is. We don't want to just reinvent anything for the sake of it. And when we look a little bit forward in terms of how do we get there? So if you want to plan for the next decade, if you look back, we see that Qt 4 and Qt 5 each lasted well over a decade, pretty much. Qt 4 was released in 2005, and it ended its support lifetime 2015. Qt 5.0 was released in 2012, will end support in 2023. So assuming Qt 6 gets released this year, how long is going to be its time span? Probably a decade, probably even more. So how do we plan for it? How do we make this last? Well, there are a few design goals and a few guidelines to guide us through the process. Pretty much, we want to start looking a little bit ahead. So the first thing that Qt 6 is going to require is a C++17 capable compiler. Practically, it means you need to have Microsoft 2019 or GCC 8 or whatever Clang is released together with an Apple platform. Those will be your minimum compilers for Qt 6. Qt itself is transitioning from the old build system called QMake onto CMake. Pretty much in the last few years, CMake has been established as the solution for building C++ code. So Qt itself will be built using CMake. It still means that QMake works for end-user applications. It simply won't be used to build Qt itself. But as don't say a warning, but if you look a little bit ahead, I can see that even your end-user application, perhaps you want to start migrating them away from QMake and towards a more modern build system. And finally, we need to tackle, as I mentioned, the landscape, which is changing when it comes to the APIs tackling 3D. So for that, we have a solution. It's something called RHI, which stands for Rendering Hardware Interface. And that's how Qt will be able to target multiple 3D APIs at the same time. I have a few more slides about that. What is the plan about this? The overall plan about this is that we have reached feature freeze just a few days ago. So in a few days, we will release an alpha of Qt 6. We'll do the usual rounds of API review and so on. And after the API is settled, we will release a beta, hopefully in October. In November, there will be one or more release candidates, maybe more than one. And finally, December this year, we're aiming for the final release of Qt 6.0. If you're really eager and you want to try it out, you can already, of course, download it from the Git repositories and build it yourself. But if you're using the binary installers, there are actually binary snapshots available in there, so you can download it right away. And one of the things coming with the first 6.0 release that has been decided is to have a reduced set of modules. I will elaborate about which modules are kind of missing at the moment. I mean, all the usual suspects are there. So widgets, Qt Quick controls, and the like, Qt 3D, Qt Quick 3D, they're all there. Don't worry about those, but a few are still missing. And for those, there is a decision to be made. So either they will be coming back in 6.1, 6.2. So we don't want to delay the release because one module is not ready. Or some of those may actually be moved onto the Qt Marketplace. The Qt Marketplace is this new distribution for Qt-related components. You can navigate to its website, or you find inside Qt Creator, and you're able to download third-party extensions. The idea is that some modules may benefit from being released separately from Qt itself. For instance, if you take a module like Qt Web Engine, which is basically wrapping Chromium, it will actually be beneficial for the end user to release that module every time Chromium releases an update, because usually these updates include important security fixes. So we don't want that to wait until the next version of Qt comes along. We want to release it immediately. And a good way to solve that problem is to make Web Engine out on the marketplace. It's one of the options on the table at the moment. All right, so this was our general intro. Let me now discuss more in detail about what's happening in the individual departments, if you want. I'll be starting with Qt Core, simply because it's one which I'm very active around. So, and I believe that there is at least one fundamental change coming in Qt Core that everybody has to see. And this is it. So the most important change happening in Qt Core coming Qt 6 will be the idea of having property bindings available in C++. So if you're using QML, you already know what a property binding is. But if you have never used QML, let me explain it to you what a binding is. A binding is a way to connect together the values of more properties in a way that the value of a given property at any point in time is automatically updated whenever other properties change. To show this as an example, I can show it to you. So suppose that, for instance, we have this little dialog right here. And this little dialog allows you to put an offer for something. Okay, so you have a spin box in which you can enter a number. And also you have a checkbox right there. And suppose that you want to enable the OK button only when the current offer that the user types in is bigger then the new offer is bigger than the current one, and of course the user accepts the terms and condition. So traditionally, the way to do that is that you need to listen to some signal emitted by this spin box, listen to some signal emitted by this checkbox, and connect those signals to a slot in which you figure out if you have to enable or disable the OK button. That's if you want the traditional way. It's a very nice way, but it's still kind of verbose. The new way, the way we want to make this possible, is by writing something like this. So I'd simply say that the enabled property of my OK button is a binding, which depends on this overall expression that I've written right there. So when the value of this edit is bigger than the current offer and the accept box is checked. So when this is, of course, true, then the enabled button is true. When this expression becomes somehow false, then the enabled button becomes disabled. And the beauty of this is that you don't need to connect anything. Automatically, whenever the value changes, or the current offer changes, or the checkbox changes, this binding is reevaluated and your enabled property is updated automatically. So that's one of the most revolutionary things that we are adding to the Qt object model. Now, there is a mandatory note. This syntax is kind of pseudocode. We're still working on what is the actual final API. So please, if you're watching this video 2 years from now, you're wondering, why does this code not compile? It's because this code is still kind of through the motion, but rest assured that this is what we want to have in Qt 6.0. Something else happening around the board. Again, we're taking this chance to do some internal cleanups. So for instance, we have taken the time to re-engineer the Qt containers. The most visible changes are listed on this slide. The first one is that the containers will finally support more than 2 billion elements, in the sense that the index type has been extended to a 64-bit type if you're on 64-bit platform. Well, for things like vectors, maybe that's unlikely, but things like strings, there are already documents or strings that can become longer than 2 gigabytes. So we want to make that possible. Another important change has been the grand unification of QList and QVector. Now, myself, yours truly, and many of my colleagues at KDAB have repeated countless times, please stop using QList, start using QVector. And we made this now, if you want, in code, in the sense that QList in Qt 6 is actually QVector. The two classes are type def one onto another, and they're keeping the good semantics of QVector. Something else happening is that QMap, QHash are finally single value classes, as the name implies. Historically, you were allowed to put multiple duplicate keys inside maps and hashes, and this just caused headaches because nobody would expect a QMap to have duplicate keys. So that is now gone. The API is now gone. And if you want to have duplicate keys, please use the right classes, which have always been QMultimap and QMultihash. Internally, all these classes have been refactored. So we have a new implementation for QHash, new implementation for QMap, QVector, even QPair now is simply an alias to standard pair. There is no longer a need to keep a class in Qt for something that the standard library just provides. And the QLink list, which is a class that virtually no one has been using, has been dropped and moved into a compatibility module. In terms of string classes, Qt has always been extremely good at providing you with very good string APIs. They're still there, but now we have many more APIs available. So QStringView, introduced in Qt 5.13, I believe, 5.12, now has a complementary class called QBitary views. They're both views in the sense they're just views. They don't own a string-like sequence, whatever it is, UTF-16. A QBitary view is just a view over shared data, whatever it is. We have added a new string view, which is called QAnyStringView, and that's a type-erased view over UTF-8, UTF-16 data. We've added a new class called QString tokenizer, which is a non-allocating string splitter. So if you have a string view, and a string view by definition does not own the data, so it does not allocate anything, now you want to split it. For instance, you have a CSV file, you want to split using comma. The last thing you want is to just call split and allocate memory to do the splitting. That is kind of a nonsensical thing to do once you have a QString view. So there's now a dedicated class that deals with string splitting in a non-allocating way. And as such, it's very fast. The old classes like QStringRef and QRegExp have now been dropped because QStringView and QRegularExpression totally replaced them. Some other things, some other assumptions that we're making, all the source code that Qt6 expects is going to be UTF-8 encoded. We live in 2020. Yes, other encodings do exist, but source code really needs to be transcoded and written in UTF-8. We extend the support, of course, to the latest Unicode standards. We support Unicode 12 with all that comes with the fancy emojis. We also support the CLDR, the Common Locally Data Repository, I believe that is. There's plenty of acronyms in programming, just like aviation. And again, these are the very latest. So, when it comes to internationalization or supporting emojis or anything like that, these are all supported by Qt. And in terms of internationalization, especially when it comes with text encoding, we took the chance to somehow remove some code from Qt core itself and move it into its own library. And I'm talking about the text encoding classes, which were around Qt core and actually contributed to a significant part of its size, simply because these classes were full of tables and algorithms. To kind of shrink Qt core for this use case, we just split it and moved QText codec APIs in its own library. Qt core itself these days can only deal with Unicode encodings. So you get 8, 16, and 32. Okay, enough about Qt core changes. Let me talk a little bit about graphical changes. So I'll start talking about Qt widgets. And if you drum roll, you may actually be wondering what's going on with Qt widgets. If we look at the documentation, you may check with me that actually no new class has been added to Qt widgets, I believe, since Qt 4.6, Qt 4.7, something like that. So what's going on? Are widgets dead? Is the desktop dead? The answer is no, of course. The answer is widgets inside Qt are essentially frozen. They're using in so many applications and so all over the place that doing any minimal change to any widget is actually going to break somebody's workflow. So the focus on Qt widgets inside Qt is really long-term stability, bug fixing, maybe some small API improvement here and there, but not much more than that. The other side of this is, why don't we just add a new widget? I mean, the existing ones won't get broken. We're just adding new ones. The actual entry barrier for new features is still extremely high inside Qt. What do I mean by that? Well, if you want to add a new widget to Qt, you need to make sure that your widget looks correct and works correctly under all the supported platforms. That means, of course, Windows, Mac, Linux, under all the available styles, under high DPI conditions. It needs to be stylable using style sheets. The barrier is quite high. It needs accessibility support, right? All these things. So for a casual user, just to add a fancy new widget, that barrier is so high that pretty much it will never get into Qt. For that reason, we're kind of encouraging people to actually contributing these widgets elsewhere. For instance, into the Qt marketplace, inside KDAB frameworks, and so on. And so right now you can download immediately if you want some extra widgets that are just available there. And if you fancy writing or sharing a custom widget of yours, consider sharing it there to make it become more mature and then only eventually land into Qt itself. Okay, so things like a K-color combo, which is a combo box that allows you to select a color. This comes from K widget add-ons, I believe, a KDE library. KD doc widgets, a brand new doc widget framework that's from us. I believe Sergio is going to talk about it tomorrow or the day after tomorrow. Phantom style, which is a new Q style targeting for high DPI screens. These are all found in third parties. Now, the fact that widgets are frozen doesn't mean that they're done. By no means they're done. There are still many, many things that need a lot of love from Qt. So we're aiming to fix a few of these things coming Qt 6. In particular, the first one is the dreaded high DPI support. Okay, high DPI has always been kind of a pain in the backside because it's very hard to get it right. Every user and every operating system and every application, should say, has slightly different ideas of what should happen when you have high DPI and you bring it to the extreme. And by that I mean you have, for instance, hybrid screen configurations. Maybe you have a 4K screen and connected to your laptop. So the screen of your laptop is actually high DPI, but the external screen is not, or something like that. Maybe you're using a fractional scaling factor, something like 125% or 175%. All of these must just work. And it's a bit tricky. Sometimes we must just require the application to make a decision. Like, I cannot guess what's good for you. You need to tell me how I'm supposed to handle a fractional scale factor. But we want these to just work. Okay, so Qt 5.15 makes almost everything just work. The few last cases should be tackled coming Qt 6. There are still new native styles coming from operating systems, like operating systems introducing dark modes or themes, etc. And those still need to be handled inside Qt widgets, because Qt widgets are supposed to look and feel native on all operating systems. The input systems are an ever-changing paradigm. So we went to simply mouse and keyboard. Now we have stylus and touch and multi-touch and voice activation, and we have virtual keyboards even on desktop applications. We have complex input methods, so you can type Chinese on your trackpad, and that will compose a Chinese letter appearing on the screen. All of these need to work, right? So these need to be handled by Qt for you. And one last thing is that RHI, which is this framework that handles 3D in Qt, may be used in the future to accelerate widget rendering and composting. So widgets have been always rendered using the CPU. That's good and bad at the same time. It's good because it gives you very reliable results on all operating systems, but on the other hand, it's slow. So can we improve the situation there, and how? This is kind of a research project at the moment. Hopefully in Qt 6.1, Qt 6.2, we'll be able to accelerate widget rendering and composting now that we have a way to abstract away the 3D graphical API on each platform. Okay, so that's enough about Qt widgets. Let me tackle Qt Quick and QML right now, because many projects we'll be doing at KDAB are actually using a combination of widgets and QML Qt Quick. By no means QML and Qt Quick are just for embedded or just for mobile applications. Actually, a few talks at this conference, including one later on this day, will be about how can we use Qt Quick and QML on the desktop to build desktop applications. Does it make sense? And if so, what are the pros, what are the cons? So what's happening in QML? First and foremost, let me start with a batch of new features that have landed in Qt 5.15. And of course, will be there in Qt 6. These features kind of give you an idea of where we're going to. So the first thing that we start to see are new kind of properties available in QML, the so-called required properties. Are properties that you must set in order to instantiate a given component. If you want kind of akin to parameters of a constructor, you must give these parameters, you must set these properties, otherwise you cannot build the object in the first place. There are a new way to create components, so-called inline components. And the most important one is actually the last one in this list, that is the usual mechanisms through which we extend QML with C++ content have been completely redesigned in 5.15. So in QML comes with extremely good C++ APIs. You can extend QML from C++, and you can extend it if you want on two different ways. One way is you have objects in C++ and you simply want to expose these objects to QML. So you have some singletons, some magic objects, some controllers, and you have them created in C++. You just want to hand them over to the QML side and let QML act on them. And the second way we actually extend QML from C++ is by creating new components in C++. So in C++, you create a class, and then you instantiate this class in QML. Now, both of these ways have been kind of changed in 5.15. Well, not changed, extended. And pretty much these ways have to do with, have been extended to work better at compile time. So for instance, here on the right, I have a class that I'm going to call radio controller, okay? And I want this to be an element available in QML. So what I'm going to do is that I'm going to decorate this with this keyword, QML element. And then in QMake, I'm going to add this snippet of code to my profile that automatically registers this radio controller as a type in QML. Why is this important? Why doing this at build time and not at runtime as we used to do is to improve tooling and to improve type safety. And that's where the trend is. We want to offload as many things as possible to compile time so that we can check as much as possible that our QML side of things is correct. Historically, that's one of the biggest pain points of QML. That is the fact that it's a dynamic language, and as all dynamic languages, it comes with kind of loose typing, and you're never sure that the object called foo is actually the object you expect to be, and so on. So we want to improve on that. We want to build on that. The first building block is actually getting as much as possible done at compile time, so that the runtime is automatically correct. And if it's not correct, you get build errors, so you cannot even run your code. So how do we get there towards a better QML? The current version of the language QML is called QML 2. So it's a great language. We have a lot of fun in terms of working with it, but there's still some room for improvement, especially when we look at big scale applications. And typically these are found on the desktop. So if I have to build a very complex application using Qt Quick, the language itself may somehow backstab me, or I may find it less intuitive than it should be. So the way forward in Qt 6 is going to be evolve from QML 2 into what we're calling QML 3. And some of the design goals are listed here. Something that we want to do definitely is going to be precompile as much as possible. Another thing we want to do is reconsider the usage of JavaScript as this kind of first-class citizen inside QML. Is it a good idea to still have it around? Maybe yes, maybe no. We're going to explain that. And then eventually build more tooling support about this. Give the build system more opportunities to catch mistakes at build time rather than runtime. For instance, if you register a component at compile time, then I can analyze your QML and immediately spot a place in your code where you're accessing a property that doesn't exist on that component. And I can do all of that again at compile time. So coming soon, not in 6.0 unfortunately, but likely in 6.1, 6.2 is going to be the new version of the QML language. We're going to call it momentarily QML 3. And a few of these ideas behind QML 3 are going to be that the JavaScript engine is going to become completely optional. So you can either enable it and then you have JavaScript, or if you don't need it, then if you want to stick to C++ as you should for your business logic, then you can actually ditch the JavaScript engine completely. We want to enable more compile time typing, more static typing. I'm not sure if you want to just extend it to something like TypeScript or similar, but anyways, more having static typing is good, and we want to have it. And we may need to just have the ability to compile QML straight to C++ code. This requires a lot of plumbing and foundations to be in place. That's why this thing is not coming just right now. But for instance, in a future evolution of QtQuick, if I have an item written in QML where I declare a property bool active, which is bound to something, in theory, this kind of code should be able to get compiled into a C++ class that does exactly the same thing and uses, for instance, the new property binding mechanism, which has been introduced in C++, to redo this binding that has been done previously just in QML. So these kind of changes are definitely great for the language, for the ecosystem, because they give us many, many more things, the type safety, the stability, and the performance that are just proper of C++, and finally they come also to QML. Now, apart from the QML language, what about QtQuick, and what about QtQuick? What about the rest? So QtQuick, in terms of graphic API, the API is pretty much mostly unchanged. You still have all your items, you still have everything you need. What is going to happen happens mostly under the hood. And in particular, the scene graph, that is the data structure that QtQuick uses for rendering, is now at the same time a 2D, 3D scene graph. This has been done pretty much to allow tighter integration for 3D content. So if you have 3D content coming from a framework such as Qt3D or QtQuick 3D, and you want to integrate it inside a QtQuick application, at least historically, the two sides felt a little bit disconnected. Now there is the ability of rendering everything using the same scene graph. The other important part has to do with the rendering itself that happens exclusively using this RHI framework. So QtQuick will be able to target OpenGL or Dark3D or Vulkan or Metal, depending on the platform that you're running, and to do that all natively. Okay, so that's great. It means that if you're running on Apple, you will have a QtQuick application targeting Metal, and you not even notice. Okay, but of course, if you need software rendering, it's still there. Just a note of warning in the sense that some desktop applications that are mixing raw 3D, such as raw OpenGL and QtQuick, are possibly affected by this change. Historically, QtQuick has always rendered just using OpenGL. Now it renders using multiple APIs. So this possibly affected does not have necessarily a negative meaning. What do I mean by that? That if you require OpenGL, then you need to tell QtQuick and RHI, I must use OpenGL because I need to render my own content. But on the other hand, if your 3D engine supports, I don't know, OpenGL and Vulkan, then you can ask RHI, hey, can I create a Vulkan surface? Yes, okay, then create a Vulkan surface, and in my 3D engine, I'm actually going to use Vulkan instead of OpenGL. Okay, so you unlock the possibility of rendering your own content using other 3D APIs if you can target those. Okay. Sometime after 6.0, it's also planned to have a C++ API for QtQuick elements themselves. So this is kind of interesting because QtQuick itself, historically during Qt5, only had QML APIs. If you need to create a rectangle, you must use QML, create your rectangle element. Now this is okay, but it's also not okay. Why cannot I just create a QtQuick scene from C++? I might just create a QtQuick rectangle, put it somewhere, and it works. Yep. So now that we have the other building blocks in C++, such as property bindings, it totally makes sense to expose QtQuick elements as C++ APIs. And so we can do that now. And finally, in 6.0, if you're using QtQuick controls true, a new style has been added, the so-called native desktop style. The idea is quite simple. That is, if you're building an application using QtQuick, you may not want it to have like a mobile style, right? So you want it to look native because you're building a desktop application using QtQuick. So in 6.0, there's going to be a native desktop style for QtQuick controls true. And so QtQuick controls is going to look and feel just like a widget, if you want. Okay. Now, I have a demo for that, but I cannot run the demo. I'm just showing the slides, but please trust me. Again, or if you don't trust me, just download Qt Quick Control Through from Git, build it yourself, and you will be able to run something like this. So to show that these are buttons and checkboxes and radio buttons with a native look and feel. Okay, I still have a couple of minutes here, so I'm just giving an overview about what's happening in terms of 3D graphics, just to explain what is this RHI thing. But it's actually very, very simple. The situation in the 3D world is this. 10 years ago, when Qt 5 was engineered, pretty much OpenGL was the API to access 3D. Yes, of course, on Windows you had Direct 3D, but you also had OpenGL to access it, so that was okay. And the Qt 5 therefore made this bet. It bet that OpenGL is going to be the universal enabler for 3D. Now, that particular bet meant that OpenGL is found everywhere inside Qt APIs. If you open the Qt GUI documentation Qt 5, you will find OpenGL classes in there. Qt Quick uses OpenGL to render itself. Qt Widgets has OpenGL widgets inside of it. In the last few years, in the last, let's say 5 years more or less, we've seen that actually this is no longer the case, right? The situation in the landscape of 3D standards is now unfortunately mixed. So you have OpenGL. We will still have OpenGL for a very long time ahead of us. That's not a problem. But you also have other 3D APIs, Vulkan, Metal, Direct 3D. So how do we target, for instance, Apple platforms that today are deprecating OpenGL and maybe in 3 years from now, they're going to remove OpenGL support? How do we deal with those? How do we deal with the Direct 3D and so on? The idea is quite simple. We're going to add, we actually already added an abstraction layer inside the Qt. So inside Qt GUI, there is now this abstraction layer called the rendering hardware interface, or RHI, and that's an abstraction over the most popular 3D rendering APIs. And the OpenGL stuff that was in there was actually moved outside Qt GUI inside separate libraries. What does this mean? It means that Qt libraries and frameworks such as Qt Quick, Qt 3D, Qt Quick 3D are now rendering through this layer. Okay, and this layer will translate whatever these APIs need to do into the corresponding native commands. Okay. Of course, if you need to just use OpenGL, you still can. You just simply need to use this, the same APIs that are simply available from elsewhere, and you're likely going to bypass this layer and just target your underlying OpenGL. But this is pretty much how these things are going to work. So in terms of end user application, RHI for the moment being is going to be kind of private API. We're still kind of finalizing it. But eventually, we will plan also to make it public, because some applications will want to use it for their own rendering. Okay, so if your application is actually using 3D today, just expect some minor turbulence coming Qt 6. Nothing big, I would say, mostly like build system changes and nothing more than that. But I would like to emphasize the good part of this. That is, if your 3D engine already targets Vulkan, then you can use this API to also use Vulkan through Qt. I think I'm running out of time. Am I tied, Jesper? Because I see you there.
Running out of time.
Okay, I thought it was interesting.
Please observe everybody how he started speaking twice as fast as soon as my face put up here.
I know that.
We have a few questions for you. So let's start with a question from, I'll just read them up for you here. Let's start with a question from Ivan, who writes, do you think Qt Quick/QML will replace Qt Widget in the future for desktop applications?
Replace is kind of a strong word. I will not use that word. I think that Qt widgets are here to stay for a very long time, because especially for certain kind of applications, the mouse and keyboard paradigm is pretty much not going to change the next 10 years at least. Right. So if you look at all the kind of applications, like for instance the ones that Kalle mentioned at the beginning, the number crunching applications, or the 3D modeling software, or anything heavy like that, it's very unlikely that they will move away from that pattern because it's a very good established pattern. So I still see widgets being used. I do see QML on the desktop. Yes, there are already entire applications written in Qt Quick and QML on the desktop. And something that we're starting to do is actually hybrid applications. So you may have your widget application, which still has your menus, toolbars, all the stuff that you know, and then some content inside of it is actually done using Qt Quick and QML because maybe you want fancy animations or that kind of flexibility that Qt Quick provides these days. Maybe something completely styled as you wish. So replace is a strong word. I'll not use replace to say that widgets are going away. By any means, I would say they will complement each other. Or maybe if you're just building a small application with which has, I don't know, just a chat program, maybe you just want to do it using QML, not widgets, because it looks fancier.
So to paraphrase the question a bit, if I were to start Qt development of a project today, and this is the very first I ever see of Qt,
right.
Where should I start the decision process of should I do QML or should I do widget?
I would probably ask yourself what kind of application I'm building, right? So that more or less should influence your first choice. Of course, widgets are always, if you want, the safer choice, because if I'm on the desktop, then building something which has toolbars, menus, and such will kind of never look alien to anyone. But yeah, I would first and foremost consider what kind of application you're building. Maybe get just your hands dirty a little bit in both worlds. Just tip your toes and kind of try to figure out what kind of UI I'm looking for here. Because if I'm looking for something completely dynamic and full of animations, etc., then that's QML, Qt Quick. If I'm looking at tons of menus with complicated voices in there, complicated entries to do all sorts of crazy stuff while doing 3D image manipulation, then I'm definitely looking for widgets.
There's a question coming in right now regarding QML versus widget 2. Frederick is asking, what about QML and unit testability? Is that something that's an issue, or?
So there are, depending on which side of QML you want to test. So there is, of course, support inside Qt Test, which is the framework that comes together with Qt to unit test your QML components. So if you're building a Qt Quick component of some sort, so you want to unit test it, I don't know, a fancy line edit, and you want to test that when you type hello, then the value of the text is hello. You can do all of that from within Qt. There are also third-party solutions such as Squish if you want to do overall UI testing of your application. So that goes one level above unit testing if you want. So you fire your entire application and you simulate the user doing something with it and expecting that when you click that button and you click that button, then this post condition holds. And you can do that as well. So there is already a solution for that as well.
Okay. There's a question from one of the people watching YouTube, and sorry to all of you on YouTube that we had a small fall out there. The question that Michael is asking is regarding the property system in C++. He's asking, is it possible to make the API for the property binding similar to Angular's reactive forms? And then he writes some pseudocode that basically goes like button.disable equal to not form.isValid.
If it's possible, okay. Two concerns there. First and foremost, it has to be valid in C++, of course, because it needs to be C++, so any other language does not help us. The second one is actually the syntax is still in progress. So we must make it in a way that, of course, makes sense. It's not too verbose and the like. The one that I showed you, it's kind of the one right now. I'm pretty sure it's not going to be the final one. But I mean, the idea is that one anyhow. So no matter what the syntax is going to be, eventually you will get a little bit used to it, as everything, right? You type your first 4 bindings and then, okay, that's the syntax, and you keep going with it. I would not worry too much unless it's really crazy. I mean, when I first saw a lambda in C++, I was thinking, what the heck is that? These days, I just type lambdas blindfolded. people get used to the syntax, I would say.
And I guess you haven't been in touch with Bjarne Stroustrup yet regarding changing C++ so that syntax is possible at all.
Probably not. But yep.
Okay, we get another question here from Hakan, also on YouTube. He writes, why didn't Qt think to move for package managers like Conan or Cargo for the Qt apps rather than moving to CMake?
Okay, that's a good question. Well, I mean, I'm not totally familiar about Conan and Cargo. As far as I know, they just help building your application, no matter what's like the build system used building that application. So perhaps there is something I'm missing there. I'm not totally sure. I mean, eventually, how you build Qt itself is not going to be that interesting because you just download binary blobs of Qt. Typically, at least on desktop, you will do that. If you want to build Qt itself, then you install CMake and build Qt. That's, again, should be a no-brainer these days, really. When it comes to end-user applications, QMake will be still around for a few years at least. So those hopefully will not be affected anyhow. But if you can read between the lines where this is going, I would suggest you to start looking into CMake. Not right now, but let's say in the next couple of years.
There's a question here from Andre who asks, given the core things like the new property system is still in flux, do you think that Qt 6 will be ready to be released?
Does that mean like will it be like feature complete, or are we going to release no matter what, even if the features are not there? Okay, that's kind of a question for the chief maintainer of the Qt project. I mean, what kind of preference is there? The property system is already in there. What people are kind of fighting upon is the actual implementation of it and what are like the concerns regarding what compilers we support and so on. And the actual syntax for this thing. If one is supposed to write using a certain syntax, maybe a more verbose syntax. And finally, of course, the end user documentation. So if I'm a user, how do I use this new thing? Can I use it with legacy code, or do I need to change all of my code to use this new property system? These are kind of the unsolved questions at this moment. So I would say the feature is there, but just like cleaning it up at the moment. I don't think that's going to take so long to postpone the release. I don't think that's good. I hope that's not going to happen, of course, but who knows in this crazy world what else may happen in the next few months.
Okay.
So yeah.
Yeah, okay. So there's a question here from Dalit, I believe his name is, that asks, are there any plans for QPainter to use the rendering hardware interface, or is it already using it?
So at the moment, it's so QPainter and QWidgets, it's not using it. It's just using regular CPU rasterizing. But yes, there are definitely plans for that to go there. I believe I already actually saw some patches for giving that kind of support. Having Painter over RHI is necessary if you want, first and foremost, to accelerate widget rendering using RHI, because widgets are drawn using QPainter. And so if you want to accelerate that through RHI, you need that QPainter over RHI layer. The second thing is some Qt Quick components, such as Quick Painted Item. I hope I spelled that right. QQPI, yeah. That thing also runs on top of RHI, because Qt Quick now runs on top of over RHI. So if you want to accelerate that, we also need the same kind of an integration. So yes, hopefully, maybe not in 6.0, maybe in 6.1, we will have QPainter over RHI, most certainly.
Okay. Well, that's about it for this time. Thank you very much for joining us here.